A very good afternoon, class. So far, we have discussed the meaning, the application, and formulation of LPP. Today, we will discuss how a LPP problem is solved. But before that, or before we begin, can you all tell me what is the meaning of optimum solution? Yes, you are correct. The minimum or maximum value of an objective function of a problem is called as the optimum solution. But the question is, how do we solve a LPP problem? Well, there are different ways to solve these problems. Now, in your syllabus, as I've told you, you will be having sums related to only two variables, that is x and y, or you can also take x1, x2. So in order to solve two variables sums in linear programming problems, there is one particular solution which is offered, that is called graphical solution. So class, today we'll be focusing on how to solve the sums graphically. Remember this slide, class? This slide I had shared in the first part of the introduction of LPP. I told you all, in order to understand a LPP problem, we should first understand the formulation part and then we move on to solution part. Yesterday class, we finished with the formulation part of an LPP. That is, we saw how in a word problem, you can represent the sum tabularly or without a table and get the required objective function, the decision variables, subject to certain constraints. And at the last, we used to write the non-negative constraint. From today onwards, class will be focusing on the solution part of how to solve LPP. And as I told you, we'll be solving it graphically. So we begin class. We take the same problems that we have finished yesterday. Exercise 6.1. I'm taking the first problem. The rest of the thing is the same. As you all know, the objective was maximum profit, constraint, decision variables. Then we saw how to formulate it. In this case, we are using a table form to formulate the LPP. Till here, you all learned, and this part is called as the formulation part. Now, from here on, you have to continue the sum like this. So as you'll see, there are two constraints over here with a sign less than equal to. Now, when we solve a LPP problem graphically, this is what is the pattern you have to follow. So our question starts from here. Maximize z is equal to 30x plus 20y. These are your constraints. In this case, we are having two inequations. So here's the solution. Consider 10x plus 6y less than equal to 60. So first, we'll change this inequation in a corresponding equation like this. Let 10x plus 6y be equal to 60. Remember class, in a LPP, none of the equations are written. We are only assuming in order to get the solution graphically. Remember class, this we had already done last year because this particular chapter you had last year as well. So as I taught you all, we have to first put the value of x is equal to 0 and then y is equal to 0. Because on the right hand side, there is no 0 available. So you can use this particular method. On putting the value of x is equal to 0 and solving, you get the value of y to be as 10. So we got our first coordinate. As we are solving graphically, we need coordinates to plot on the graph. So we got our first coordinate, that is a is 0, 10 because the value of x is 0 and y is 10. Similarly, in the same equation, when we put y is equal to 0, we get x is equal to 6. So we got our second coordinate, b, 6, 0. In the similar way, I solved the second inequation as well. So first, we converted into a corresponding equation with an equal to sign. Then we put x is equal to 0. After that, we substituted y is equal to 0. And then we got both our coordinates, coordinate C and coordinate D. In this case, class, you can see the coordinate I got here is 8.75, which is as good as 8.6. So followed class, the very first step of the solution is to change the inequations in corresponding equations and find out the coordinates. Now, as you'll see, all the coordinates are positive. We'll be drawing only two axes, x and y. Now, in order to take the units, you can see the smallest number among all the variables. So the smallest number is 6 and the maximum goes up to 10. So I'll take the graph like this. Now class, you can practice on a graph paper, but I suggest you all to practice in your notebook as well. Because sometimes in board exams, you won't get graph paper. So it will be very difficult for you all to plot the graph. So as you all can see, I have taken two axes, x and y, with exact 1 centimeter each. So from your scale class, you can measure exact 1 centimeter. And yes, keep in mind the difference between these two lines in your notebook is not 1 centimeter. So be very careful class, because this I had already taught you last year as well, that you have to take exact 1 centimeter from your scale. So after plotting, you can write the scale first. 1 centimeter is equal to 1 unit on both the axes. After preparing the graph to plot the coordinates, the next step is we'll start plotting the coordinates. So as you can see, I have plotted a coordinate which was 0, 10. That means value of x does not exist. So on y-axis, I plotted 0, 10. In the same way, I plotted the second coordinate b, 6, 0. And join both the lines, both the points like this, and you'll get the line of the equation. Then you can write the equation on the line. 10x plus 6y is equal to 60. I hope it's clear up till now, because this you have already done last year. As you can see class, I have also plotted the second line as well. That was, I told you all, 8.75 is as good as 8.6. So approximate value you can plot 8.6 lies between 8 and 9. Similarly, I plotted the fourth value D, 7, 0. And as you can see class, the two lines intersect at a point, and I've named that point to be as E. Now can anybody tell me what we used to do further? Do you all remember? Correct. We are gonna find feasible region. Now what is a feasible region? We'll see in the further slide. Now as you can see class, this inequation has the sign less than equal to. That is this one which I'm talking about. So remember class, last year I told you, when the sign represents less than equal to and greater than equal to, what you have to do? So less than equal to का मतलब होता है towards the origin, whereas greater equal to का मतलब होता है away from the origin. So coming to the next point class, depending upon the sign, you have to shade the feasible region. So if the sign is less than equal to, that means you will be shading towards origin. That means towards the left hand side like this. If your sign is greater equal to, that means it is away from the origin. So you will have to shade that side like this towards your right side. So remember class, if it is less than ka sign, left side. If it is greater than ka sign, right side. Okay. So left hand side is towards the origin. That means this particular part. And away from the origin means the greater equal to, that is the outside part. So with the help of this particular topic, I have shaded the feasible region like this. So can you see? It was less than sign. So I shaded my region towards the origin, that is towards O. So now we are talking about feasible region. What is the meaning of feasible region? So feasible region means it is the common region determined by all the constraints. In this case, we had two constraints, and this is the feasible region which is determined by the constraint. So I hope till here the concept is clear, because till here you already studied last year class. So as you can see, I have highlighted the major points, the corner points of the diagram like this. And I've written OCEB is the required feasible region. Now class, if you see on x-axis, points from 0 to 6 are all satisfying the condition. Also on the y-axis, the points 0 to 9 are also satisfying the given conditions. But in order to find the solution, it will be too many points to be plotted. So we take a shortcut method, and that shortcut method is called as the corner points. That is why class, if you see, I have highlighted the 4 points like this. So that was O, C, E and B. And I've written OCEB is the required feasible region. And as we have taken only the corner points of the shaded region, this particular method is called as corner point method. Now, as you can see class, in this 4 alphabets, I have the value of origin, and origin is always 0, 0. I have the coordinate of C, which I had solved earlier. It was 0, 8.6 or 8.75. Talking about coordinate B, it was 6, 0. But what about the new coordinate which we got just now? Coordinate E. So in order to find the coordinate of a new point, we always have to solve the two equations simultaneously. So as you can see class, the point E is made by two lines. These two equations, 5x plus 4y and 10x plus 6y. So I will take these two equations and solve them simultaneously like this. Now as you can see, there are no alphabets which are same. So I will multiply equation 2 by the number 2 so that I can make 5x as 10x. So on multiplying 2, I get the third equation, 10x plus 8y is equal to 70. From that, I will subtract the first equation, 10x plus 6y is equal to 60. On subtraction, the sign changes. I got the value of y. Substituting y in the equation in any out of the 3, in any one, you can substitute. So you found out the coordinates of the new point E, which is 3, 5. Now we have to find the objective function z. So as we saw, we have to find the optimum solution. An optimum solution will be given by the objective function. So class, whatever feasible region coordinates you took, you will be substituting in the value z. So our feasible region was O, C, E and B. So as you can see class, I have substituted all the 4 points one by one. At point O, 0, 0, 30 into 0 plus 20 into 0 gave me 0. At point C, the point coordinates were 0, 8.75. So 30 into 0 plus 20 into 8.75. I got the answer to be as 175. Then I substituted point E. I got the answer 190. And then the last coordinate, point B. I got the answer 180. So if you paid attention class, the question was asked maximization. And maximization means we have to take the maximum possible value. and maximization problem always denotes profit. So the final answer will be the profit is maximum at rupees 190. This is the highest, and that is at point E, where the value of X was 3 and the value of Y was 5. So in this way, you have to solve the entire LPP problem. For your understanding, I've also solved for your second sum. So pay attention class. If you still have some doubts, you can refer to the second sum which I am explaining again. So in the second sum as well, we saw that there were 3 constraints, but the variables were 2. That is for the 1 and for the 2. This was the representation which was done and explained by me in your previous class. So in this case, we are having 3 constraints with us. So we'll solve them one by one, like this. So this is your main question with 3 constraints. This is your objective function, minimize. They're talking about minimization. They always refer to the cost of production. So consider the first equation and you will change it into a corresponding equation with an equal to sign. Then we'll put the value of X to be as 0. In the same equation, you will put Y to be as 0. And then you will get the coordinates A and B. Similarly, I have taken the second inequation, change it into an equation, put X is equal to 0, then put Y is equal to 0, and then you get the coordinates C and D. Again, we consider the third inequation. We change it into an equation, put X is equal to 0, put Y is equal to 0, we get the coordinates E and F. So after that, we will check which is the minimum value. It starts from 1. Maximum, it goes up to 40. So in this case class, I am taking 1 centimeter is equal to 2 units on both the axes. So I have taken the table of 2 like this with exact 1 centimeter each. Then we start plotting the coordinates and make the 3 corresponding lines of the equations. So AB, CD and EF. Remember class, in every slide you have to name the coordinates as well as write the equations on the line. So as you can see, the first and second equations are framing a new point. So you can name it as point G. After making this particular diagram, now it's turn for the feasible region. So class, remember feasible region, I had told you all, we have to see the sign. In this case, the sign is representing greater equal to. So greater equal to means the right hand side, as I told you all, away from the origin. So as you can see, all the 3 lines, when I plot, I get the region which is away from the region like this. So when I highlight it, I have to take the common region, which is common to all the 3. So then I get the feasible region to be as point A, point G and point D. These are the border lines equation of the feasible region. So AGD is the required feasible region. Now in this class, you have point A, you have got point D, but you don't have the values of point G. So remember, what did I tell you all? In order to find the coordinates, you have to solve 2 equations simultaneously. So in this case, point G is made by the lines 2x plus 3y is equal to 22 and 2x plus y is equal to 40. So I will take these 2 equations and solve them simultaneously like this. So as you can see, here 2x is common in both. So I have done subtraction. In subtraction, your sign changes. So I've left with -2, y is equal to -12. Minus minus cancel, y is equal to 6. You can substitute y in any of the equation and get the value of x like this. So here you can see we got the coordinate g to be as 4, 6. Now to find the objective function z, so we have to substitute all the three, starting with point A, 0, 14, point G, 4, 6, and point D, 11, 0. So the question was about minimization, and minimization means you have to take the smallest number. So the smallest out of the three is 24. So our final solution goes like this. The cost is minimum at z is equal to 24 rupees. That is at point G, where x is equal to 4 and y is equal to 6. So this is the final answer. So I hope class now you all are a little bit clear how to solve the solution of a LPP problem graphically. In order to practice, as you all have seen in the starting first part or second part, sorry, we have already finished 6 sums. 3 I had solved and 3 I had given you all for homework. So you can solve sum number 7, sum number 4, sum number 6 and see whether you are able to get the final answers or not. So class, this is the way to solve the problem graphically. Now these were simple types of sums. And as you all see class, when I was talking about the feasible region, one region came towards the origin and the other region went away from the origin. So in the further lectures, we'll be seeing what kind of feasible region is called as bounded feasible region and what kind of feasible region is called as unbounded feasible region. And then we also have sums on special cases. So we stop here for today class. I hope the concept is clear and you practice, keep learning and stay safe. Thank you so much.